Hi, and welcome back to the History and Philosophy of Science in 6 Easy Steps. This is your Week 5 review and Week 6 introduction. And stay tuned next weekend. I'm going to have a wrap-up video. We'll talk about your grades, that sort of thing. So don't tune out. We do have a couple assignments this week as well that we'll discuss later in this video. Okay, I want to start by wrapping up Week 5. We were talking about the importance of science and kind of asking the question of how important science is and whether it's really essential to modern society and modern life. And I think the answer to that is a resounding yes, but let's get into that a little bit more. Thank you for your great contributions and thoughtful contributions to the wiki. I just want to highlight a couple things. Copernicus. Many people would point to Copernicus' heliocentric theory as being the beginning, the real beginning of the scientific revolution. Why? Because it changed the way we view the world. It was a final break from the Aristotelian way, which was still kind of a way of viewing the world just purely philosophically. Even though it was an orderly view, it was a philosophical view where problems were worked out kind of just in your head based on notions that you had about the world. Other people looked at the world through a religious lens and thought about maybe the gods or God doing things a certain way. The scientific worldview, however, gave us this model of the world, well, really introduced the idea of having a model of the world that we could test, that we could experiment with, and that we could figure out and expand upon. All right, and that's kind of where we're at today in the modern world, is that we look at everything that way. We can approach problems using conjectures and refutations, and that's the scientific worldview. And that pretty much began with Copernicus. Not exactly, but that's kind of where there was a clear beginning we can talk about. X-rays are one example that one of you mentioned about a very important technology that arose out of scientific exploration. Although you kind of have to ask the question with X-rays, is that a technology or is it science? And was the discovery of X-rays, was it scientific, or was it more of kind of a technological thing where it was noticed and then it was replicated in technology? I'm not sure. Let's talk a little bit more about technology in a few minutes. Nuclear weapons are another example of a way that science was used. Einstein's theories were used to develop these very powerful and destructive weapons. And of course, nuclear power as well. So we don't want to leave that out of the equation at all. There were benefits as well as harms done by that technology. And then relativity and GPS satellites. This was an interesting one. This is a very clear case where without this theory of relativity that Einstein came up with, we would apparently not be able to run our GPS satellites correctly. All right, they would fall behind in time, or their time would get messed up, and so without that theory, we wouldn't be able to correctly operate them, at least in an efficient way. I suppose through guess and check and methods like that, we might be able to improve them. Now, this kind of the debate about, or the question about whether science and technology are different or how they're different has been something that we've been coming up against again and again in this course, and that's because there almost really is no clear line of distinction all the time between science and technology, all right, or between science and engineering, if you like. There's something called applied science, which is really just engineering, or very similar to engineering. So, but I do want to talk about how Kuhn's view might impact this discussion. Remember, in Kuhn's view of science, science is not necessarily leading us toward a truer picture of the world, because somebody might be tempted to say, oh, well, science is when we're talking about discovering the way the world works, okay, in general, a true view of the world. But what Kuhn would say is, well, that's not necessarily true. And see, I think Kuhn's view leads us to this view of science where science is really kind of like a form of technology. It's kind of like a technology of the mind. We build these models of the world in order to solve problems. Whether those problems don't have to be practical, but they're problems nonetheless. And so we build theories, and then when our view of the world, when our worldview, our paradigm stops being able to solve the problems that we're looking at, then we look for a new paradigm, or we develop a new paradigm that's able to solve new problems or a broader range of problems, and so on. Now that's very similar to basically what technology does, is solve problems. Now in the case of technology, they're typically practical problems, okay? But I guess what I'm saying is, in Kuhn's view, the scientific theory would be kind of like a problem-solving framework, all right? And that's, you could think about that as a form of technology. But I think we can make some distinctions between science and technology, and here's why. For one thing, technologies might be isolated. So let's say I'm a Neanderthal man, and I happen to pick up two rocks, and I'm just banging rock. I'm walking around banging rocks together. And I pick up two rocks, and I bang them together, and there's a big spark. Okay? Now, I have no idea why this happened, and maybe I think that the gods did it, or maybe I think it was magic, that I have some magical powers, or maybe I think it's just random chance, and I don't even question it. But I take the two rocks, I put them in my little pack, and now I can start fires whenever I want to. All right? That is a form of technology. And yet, I don't think anyone would argue that I was doing science there. All right? At least not according to Popper's view, certainly. I'm not making any conjectures and trying to refute them through experiments or anything like that. So here's the distinction. I could start doing science, even as a Neanderthal man, if I started to try to figure out why it worked, or maybe even just try to figure out which rocks worked and which rocks didn't. Or maybe to see if I could take this knowledge and make it broader, right? The idea of sparks, for example. What are sparks? All right, and maybe I'd start coming up with theories about light and about heat and about chemical reactions. And then those theories I could expand and use them in other areas of my life. Maybe I could develop gunpowder. Who knows? So what I'm saying is, when I start to do science, what I'm starting to do is I'm starting to develop a model that is more broadly applicable than just these two rocks in front of me right now, than just this technology. And that model, hopefully, will lead to more technologies. And so there's this interplay. And then, by the way, those technologies will help me to develop my model further, perhaps change my model, make it better, maybe completely change it, like a paradigm shift. So there's this constant interplay between science and technology, but I think we can make a distinction. Another distinction we can make is that science is not necessarily practical. So there are a lot of scientific theories and a lot of scientific research that's done, and it's often kind of disparaged for this reason, that they're not necessarily practical. If we're looking at, maybe the mating behavior of bears, or the origin of the universe, or a lot of these things, dark matter, people would say, well, what practical use is that? Well, maybe not now, but there's a lot of areas where that eventually does become practical. In fact, I think one of the amazing things about science is that I think pretty much this almost always happens. It almost always becomes practical at some point. Because as you use these different pieces that seem impractical to build a more, I don't want to say a more accurate worldview, but a more powerful worldview, then you are able to attack more problems, a broader range of problems, solve them more efficiently, whatever it might be. Okay, so one thing I did want to talk about is I was trying to think about technologies in which it was clear that science and the scientific way of looking at the world and doing things played a key role. And one I came up with is the role of DNA and an understanding of the DNA, which clearly came from scientists applying the scientific method. And they were basically, Watson and Crick and Rosalind Franklin and Maurice Wilkins were just trying to find the structure of DNA. That was pure research. Now I'm sure they envisioned that there was a lot of practical potential from this, but it was pure basic scientific research. And the understanding of DNA has brought about a whole range of new technologies that we have. We can now not only identify people through DNA, but there's the promise we use genetic engineering now to literally go in and change the DNA of crops. And in the future, and even right now, we're starting to see genetic therapies for humans coming along, RNA interference and other other therapies that have really mind-blowing potential. And none of those things would have been possible without the basic research on DNA that led to the Nobel Prize for Watson and Crick. And yeah, I think I'm sure there's lots more examples that we could come up with, folks. But we'll quit there. Okay, so I think it goes without saying that science is important and has impacted our lives tremendously, and the way we view the world. We no longer think about it as the gods and goddesses doing certain things, and now we look at the world and problem solving in a different way. I think, at least a lot of people do. Okay, let's look at week 6. So here's a preview of week 6. Week 6 is going to kind of take us back to week 1. Now, when I had you make that graph for your first assignment in week 1, my first goal was that you would basically get an overview of the practice of science through history, when it started, what sorts of things people did, the people who were involved. That's what I wanted. But my secondary goal was that you would see the shape of that graph, that it was an exponential curve. Science and technology have shown exponential growth over time. Now, that's where we're going in week 6. We are going to ask the question of what are the implications of that exponential growth? What sorts of things might we expect in the future from science and technology? First of all, why would it be exponential? Now, this is an interesting question. Why is it not linear? And I think the basic explanation for this is that it's because technologies and science are not just additive. They're not just adding to each other, because each time you get a new technology or a new theory that enables you to develop your ideas or develop your technologies, you're building on the last one in a multiplicative way, not an additive way. So, for example, a new technology like Ray Kurzweil in the book that we're going to read, he mentions like the opposable thumb. That's a sort of a technology that was developed. That new development of the opposable thumb opened up a whole world of new possibilities. It had a multiplying effect, had an exponential effect on things. And we could look at the same thing with, say, the computer. All right, the computer didn't just add to other technologies. What it did is it made an accelerated rate of growth possible. Or robotics, same thing. It makes an accelerated rate of discovery of new technologies possible. See, that's the thing. Each discovery makes the rate of new developments and new discoveries increase. Okay? So the rate of addition of new discoveries continues to increase because each discovery enables faster discoveries in the future. Okay? It enables more discoveries, faster rate of discoveries, and so on. So we see this exponential growth. Now, if you look at that, though, what are the implications for the future? You know, Ray Kurzweil in his book, he brings out that most of us view the world linearly. We tend to think things are going to continue to progress at the same rate of growth we see currently in our lifetimes, for example. And we tend to be linear in our views. So we think things are going to grow in this kind of linear way. But if you look at history, as we have done, you see that that's really not the case. Things have not grown linearly, they've grown exponentially. And that has really some pretty amazing and controversial implications or potential implications for the future. That's what we're doing this week. I think it's a cool way to wrap this up. A look to the future, a very possibly you could view it as a very optimistic view of the future, or maybe not, and that's what we're going to get into. Your first assignment for this is, first of all, you're going to read the first chapter of this cool book, The Singularity is Near by Ray Kurzweil. He's an inventor and pretty prominent guy in technology in general. And you're not going to read this whole book, obviously. You're going to read the prologue in chapter 1 is what I'm looking for you to read. And that's a pretty good pretty good little chunk, but very important. It's packed full of stuff. The idea for the graph in the beginning of this course came from some graphs that he's got in this book in that first chapter. So you're going to read that, and then I have 2 videos, and you can choose one of them to watch. They're both about Ray Kurzweil's views. One of them, the one called The Singularity is Near, has kind of a storyline to it and a plot. It's more like a regular movie. It's interspersed with more documentary sort of interviews and stuff. The second one, called Transcendent Man, is pure documentary. They're both informative. It's just up to you which one you want to watch. If you've been in my class and you've already seen the one with the virtual lady, Singularity is Near, you'll probably want to watch the documentary so it's not as quite as redundant for you. There is some redundancy, obviously, between the 2 movies. So you'll do the reading, prologue in chapter 1 in Singularity is Near, and by the way, the link to that, the PDF, is up there on the site. You pick one of the movies to watch, and then we've got 2 assignments. One is that we're going to have a forum in which I want you to respond to the predictions of Ray Kurzweil. I want you to answer questions. The questions you could respond to are things like, do you agree with him? How do you feel about what he says? Do you think it's scary? Do you think it's optimistic and hopeful and exciting? Do you think he makes good arguments for his points? And in all these things, be sure to refer specifically to both the reading and the videos, and to use clear logic and organization. And then I want you each to respond to one of your classmates' responses. And again, you've been excellent with that, being civil and positive, and I'd like to see that continue. But again, be thoughtful and reasonable in your arguments. And then the final assignment for the course is an essay. I want you to write about the impact of science on your life, your worldview, and or your future. So, and again, in this essay, respond to the content of this course and reference the content of this course to get full credit. But I'm looking here for you to tell me, to be personal here, in the sense of, what does science mean to you? That's really what I'm looking for. And use references from the course, so things you've learned in terms of philosophy or history of science, or in this week, what is going to be happening in the future possibly, and what that means to you. It could have to do with career goals, but it certainly doesn't have to. I know that not all of you are probably intending to be scientists, but even if you're not going to be a scientist, how has science impacted your life now? How is it doing so now? And what about in the future? What do you think? What do you hope for in the future? Another way of looking at this is, what would your life be without science? I mean, that's one way to approach this. So that is going to be your final assignment. And again, in terms of that, you don't have to think just in terms of technology. I think I kind of neglected in our week 5 review that science has also, I think, had a big impact on the way we think about life and the world and the way we look at things. And that could also, its effect on religion, for example, could come into play. And so feel free to discuss those sorts of things as well. By the way, I did put a little PowerPoint up there from Dr. Bent about religion, creationism, evolution, and science. And it's one example of a way that religious people have been able to reconcile the two. Okay, so don't think that they're totally irreconcilable. But again, that's one thing you could think about. So I hope that you will enjoy this reading. Again, don't be scared by this. You're not reading the whole book, although I would encourage you to. It's really jam-packed with information. He does a great job. He's got a great index, references, appendices, notes. Amazing job this guy has done. And the videos are lots of fun as well. I hope that we'll have a good discussion on the forum. You guys have been great in this course. I've really enjoyed it. And again, tune in next weekend for the final video. All right, have fun with that.